Now, in this lecture, we will discuss the performance consideration. Two key factors in the commercial success of a computer are performance and cost. The best possible performance at the lowest cost is the objective. Now, here if we see the price per performance ratio is the common measure of the success. Now, to improve the overall performance rate by keeping the price constant, how can we do means here two methods are given. One is how fast machine instructions can be brought into the processor for execution, and the second one is how fast the instructions can be executed. Now in this chapter we are going to discuss the transfer speed of the data transfers. Okay, data transfer speed, nothing but what, how fast machine instructions can be brought into the processor for the execution. Now if this is the processor and this is the main memory, processor speed is high and main memory speed is low. So to transfer the data at the processor speed, then we can improve the system efficiency, or the transfer rate can be improved. So that can be achieved by using the parallelism. Now the effective way to introduce parallelism is to use an interleaved organization. What is interleaved organization means? The complete memory is divided into memory modules. So now instead of taking a large memory area like this, so here memory modules, complete memory is divided into parts. So those are called as a module, memory modules, and each module has its own address buffer register and data buffer register. Memory access operations may proceed in more than one module at the same time. So the parallel access to these modules is possible. The average rate of fetching word from the main memory can be increased. So if parallel accessing, if the processor is fetching the data from the more than one module at a time, then the transfer rate can be increased. Now here two methods of address layouts are given. One is a consecutive word in a module. Another one is a consecutive word in a consecutive module. Now in a consecutive, now in this, if you consecutive words are placed in a module. Now if with this, if module here, the depending upon the higher order bits are indicating the module and lower order bits are indicating the address. So the total two fields are there in the memory address. So now if one module is accessed means what? From this module only the consecutive locations are accessed. So means what? When a block of words is transferred from main memory to the cache memory, only one module is busy at a time in this consecutive word in a module. Now coming to the consecutive word in a consecutive module, now higher order bits are the address bits and lower order bits are the module with the given address. So different modules are selected. Now while transferring a block of data, several memory modules can be kept busy at the same time. Now with this, what average rate of the data transfer from the main memory to the cache memory will be increased. Now here memory is no need to wait for the data. Now here one after the other uh, uh, parallel accessing is taking place, the data transfer is increased. Now here one example is given. Data transfer of block from main memory to the cache memory. Now if this is the cache memory and this is the main memory is designed with the DRAM. Designed with the DRAM, and DRAM is slow compared to the cache memory. Cache memories are designed with the SRAMs. So now here a few specifications are given. Block of data is needed to move from main memory to the cache memory. Now here the block size is what? 8 words. Block size is 8 words. Now one clock cycle, these are the specifications given. One clock cycle for sending address to the main memory. So now if the processor is generating the address, to send this address to the main memory, it takes one clock cycle. And already we have studied the DRAM. So 8 clock cycles to access the first word from the main memory. This is the main memory, normal memory. Now here the consecutive words are stored like this. To access the first word, why it is taking 8 clock cycles means already in the DRAM we have studied. The address will be divided into row address and also column address. Once the row is activated, that complete data is loaded into the latches, and after that, depending upon the column, it will get the data from the particular column. So now consecutive locations means what? Automatically this column will be incremented, and the consecutive column addresses will be consecutive column addresses will be accessed and the data will be taken. Now to access the first word, it is taking the 8 clock pulses. Now afterwards, now in 8 words, the first word is taking the 8. And for the remaining 7 words, it will take the half of the time. Why? Because once the row is activated, no need to activate the row again and again. Only columns are activated. For that, only 4 clock cycles are required for the remaining 4 words. And one more last clock cycle is needed to store the data from the main memory to the cache memory. This is for the last 8th word. Now coming to the remaining 7 words. So when these 7 words are accessed by using these 4 clock pulses, that time only the remaining 7 words are sent from the transferred from the main memory to the cache memory. But the last word which is accessed to send from the main memory to the cache memory, one more clock cycle is needed. Now, if we calculate the total number of clock pulses, clock cycles for the memory for the transfer, it is taking 38 clock cycles. Now, if instead of taking the large main memory, if the interleaved method is used, interleaved memory is used, means what? Four modules are connected. Now these 4 modules, to send the address, first it is taking the 1 clock cycle, and to access 4 words from the parallel accessing. To access the first word from the module, it takes the 8 clock pulses. In this 8 clock pulses, total 4 modules are operated and 4 words are taken, and next 4 clock cycles are for the, now total 8 words, only here 4 modules are used. So first 4 words are came out, and for access the next 4 words, it needed the next 4 clock cycle. Why? Because already we have seen for first word only it will take the 8, from the next word onwards it will take the half of the time. That's why only 4 clock cycles are needed to access the next 4 words. And at the same time, the first 4 words are sent to the cache memory by in this 4 clock cycles only. The first 4 words which are accessed in this 8 clock cycle, that will sent to the cache, and the second 4 words which are accessed to send these 4 words to the cache memory, next 4 clock cycles are required. Now total here, if by using the interleaved memory, only 17 clock cycles are needed to transfer the block of 8 words, 8 words or one block from the main memory to the cache memory. Now with this, by introducing the interleaved, the overall data rate is increased. Now coming to the hit rate, miss penalty, and average access time. Now what is hit rate? Now if this is the cache and this is the processor and main memory, whenever the processor need the data, first it will search the data in the cache. If the data is available in the cache, then that is called the hit. Now hit rate is equal to number of hits divided by the total number of attempts. The total number of attempts or number of hits plus number of misses. So now what is miss rate means? If the processor is searching the data in the cache, if the data is not available, then that is called the miss. And the miss rate is equal to 1 minus hit rate, or 1 minus hit rate, or number of misses divided by total number of attempts. Now coming to the miss penalty. If the data is not available in the cache, then that is called the miss. Thereby what? Processor will check the data in the main memory. and how much time is needed to access the main memory, that is called the miss penalty. So now if we take the average access time, TAVG is equal to what? This is H is nothing but a hit rate into C is nothing but what? Access time to access the information in the cache. So plus 1 minus H is nothing but what? If the data is available, then that is fine. If the data is not available, then it has to go to the main memory. If the miss is occurred, so miss rate, 1 minus H is nothing but what? Miss rate into M. M is nothing but what? Main memory access time or miss penalty. So this is the average access time when only one cache is introduced. If the two level of caches are introduced on the processor, if the cache is on the processor chip. Now this is the processor, one more cache is introduced on the processor chip, and this is this level 2 cache chip, and this is the main memory. Whenever the processor need the data, first it will search the data in the L1. If the data is available, then that is called the hit rate, H1. And how much time is to access, that is called the C1. Plus, if the data is not available here, then the processor will go to the L2. Now, at the time, what miss is occurring here? So that's why we have to take the miss rate of the cache 1 and hit rate of the, if the data is available, then the hit rate of the cache 2 and accessing time of the cache 2. If the data is not available here, then the processor will check the data in the main memory. If processor is checking the data in the main memory means what? Miss is occurring in the L1 and miss is occurring in the L2. So that's why we have to take the miss rate of the cache 1 and miss rate of the cache 2, and the accessing time of the main memory is nothing but what? Miss penalty. M is nothing but a miss penalty or accessing time of the main memory. So M, this is the total average accessing time when two level of caches are introduced.